Okay, guys, we'll do something with our calculator too, because it's kind of cool. Where do parameters come from? Well, you've done these before. You maybe didn't realize it, but you have. Okay, guys? This is the x, right? And this is the y. Now, when we are going to be doing polars, okay, guys? Pay attention. We're going to be doing polars, and we're going to be doing vectors. This is where it ties in. I'm sorry, what? Okay. Does it go by Ori? Okay. Okay. Look at the circle. Okay, guys? What is the cosine of theta equal to? Now, you guys, this is a free response question on the exam. So what I'm doing is previewing polars, parametrics, and vectors. They're all tied together. They're all very similar. The cosine of my angle is x over 1. What's the sine of my angle? Is y over 1. So in my ordered pair, x, y, and you were taught the unit circle this way, it's the cosine of my angle and the sine of my angle. I don't care if you call it theta or you call it t. So it's the cosine of t. It's alphabetical. It's how I remember it. Okay, guys, not right now. So that's how you get a circle. If you let x equal cosine t, y equals sine of t, that makes sense now that you get a circle. Well, here's what we're going to do. We're going to take this. We're going to graph a circle. We're also going to graph the sine curve, but we're going to do it parametrically. So I have y equals the sine of x, and now I'm going to need to figure out what the parametric equations are going to be to graph that, because I can. So x equals and y equals. What if x is equal to t? If you have a homework problem that does this, then what would y be equal to? If it's the sine of x and x is t, y equals the sine of t. And what do you want your t to go between? No, t. 0 and I want a full cycle. Nope. No, we're going to do this on our calculator. So let's take a second to get my calculator up. So if you want to get your calculator up, because this is really cool, I'm going to have to change some settings on my calculator to do it. Make sure you are always in radian mode. And what about the x's? X's are going to be between. What are x's going to be between? -1 and 1. And what are the y's going to be between? -1 and 1. Okay, so I'm going to get my calculator. Yeah, just going to get those. I can do this. Anybody else need one? Anybody else need a calculator? Where are your calculators? Do you have your calculator with you? I only have one there. You don't have to look on it. That's all I got. I could do the inspires, but they're not here either. Okay. So we are going to go to mode. We're in parametric. And we're going to go down. I want to do this simultaneously, because this is cool when you do it simultaneously. Actually, David could come up and do it. Go to the board and operate the calculator. I don't have to do it. Come on up. Well, we're going to change this from sequential to simultaneous. That's just my splash top. Ignore it. Ignore the man behind the curtain. What movie was that from? Good, you knew something. I don't even think I can say go home and ask your parents who said this. After all, tomorrow is another day. Go home and ask your parents. Tomorrow is another day. I'll worry about it tomorrow. Okay. No, it's older than that. That's why I said I don't know if your parents would know. We're going to go to simultaneous. Okay. Now, come on up. I didn't write them down, but okay, guys. X is going to equal the cosine of t. Y is going to equal the sine of t. So you're going to have to enter it in. Go ahead, David. First off, do you want the little circle trace? Or you just want to have it? Okay, like that. This is x1, y1, and then in x2 you're going to put in t, and in y2 you're going to put in sine of t. Cosine of t and sine of t. You have to delete or clear, yeah. We're going to get there. Okay, now the next one. Go down one more. There you go. Whoops, too far. X2 is t. And notice it doesn't highlight until you have both functions in there. Sine of t. Yes, it is. Did you just Google it? Most of you probably haven't even seen it. Okay, check window now.
Wait, so it's the next one's t and then sine. Whoa, man.
Now, we want to go from 0 to 2 pi, right?
That was wicked. X98.
T-step, make it 0.1. Because one is the sine curve, the other is the circle.
Hey, what's the
Okay.
next one?
And then x min, how about negative 2 to 2? So you see enough. And same with the y's. Okay, press graph. You were going to get both. Oh, I didn't do the x's far enough, did I? Notice the quadrants you're going in, and look at you're getting the sine curve, but I messed up on my window. The x's go all the way up to 2 pi, right? Max is 2 pi. No, I got to go to 2 pi. No, I don't want 57. Just there, 2. Okay, that'll work. Okay, that's where the sine curve comes from. That's connecting the sine curve to the unit circle. I think that's cool. We'll put it back up in a second. So those are the quadrants. I don't know if you guys kind of get that. What's my view? Why is that so weird? Oh, they give me my table. They don't give me my window. Okay. There's my window. 0 to 2 pi. The x's go all the way out. You have to get out to 2 pi. So I would have just typed in 2 pi. It doesn't matter. Now maybe I want to do a zoom fit. Let's try that. Is the circle more of a circle on that? I can't do square because it won't be big enough. Okay. And then we're going to see what kind of questions you have. Oh, it's even more of an oval. I like mine better. I'm sure there are questions. It's kind of cool, isn't it? Why is what? Because I only started at 0. Yes, your window's not big enough. Window has to go up to 2 pi. Make it 7. No. Now with it. Because the sine curve, x is going to go between 0 and 2 pi. Why do we have to go out to 7? That shows you the connection between the unit circle and the sine curve. Remember, t went to 2 pi. You guys? Guys? Duncan? T goes to 2 pi. And how did we define x? To be 2 pi. That's why I had to go out that far. That's where I messed up. X is between 1 and -1 for this function, yes, but for this function, x is between 2 pi and 0. Did you try the homework?
So what's like, so we got this right here. That's what we do with this to answer a question.
I didn't ask a question. I was just showing the connection between the sine curve. Not really a question. Not now. Okay, there it is. It's kind of cool to see that. So these are expressed parametrically. So I get things that are not functions. So if we want to look at the homework, we did problem, what, 1? Yes? Let's do some problems. Because this is very new for you and it's sometimes hard. So you should have a book. Now, we have a homework quiz tomorrow through 1-6. 1-4 through 1-6. Not 1-7. And then we'll do questions tomorrow on 1-7. And you have an assignment, a review assignment Monday, more questions, get your homework quiz back. And then on Tuesday is your individual test. Yes. No, no 1-7. Oh, want to get to finish the last one? Yeah, let's do that one. No, I think there's only one left, but let's do that. Are there 2 left? Oh, well, I thought I only had 1.
Example 3.
Is it down? Oh, there we go. Okay, it's not a function. Oh, you know what I could do? Hey, guys, what I could do is I could flip x and I could flip x and y and solve for, or I could try to solve for y, but I can't even do that. So that's not going to work. So I'm going to do it parametrically. So what do you want x to be? Think of the one we just did. What if y is t, then what would x be? If y is t, yeah. And it's just, I don't know how you teach that. You just have to think through it. So should we graph that? Because I want to write it parametrically. I could make x equal to t, but I can't solve for y in terms of t. I'm going to write it parametrically. Yeah, it's adding a third variable because then I can graph it. So let's try that. I'm going to use my graphing calculator, if I can find it.
What's this last? 3.
This is example 3. So we're going to go y equals. We still have to do a little work. I'm going to clear everything out. And yeah, we're probably going to be using calculators. Because this is so weird. Okay, so this is t to the 4th minus 3t squared. Oh, I hate that when I do that. We're going to try that again. T to the 4th. Yes, I forget that I have to go back down. Minus 3t squared. And then this is t. Now I've got another problem. I got to figure out my domain and my range. Okay, what would you like t to go between? Because that's going to determine everything. Keep in mind, I'm going to raise t to the 4th power. So the minute you get to 2, you're up to 16. Just add a new page. Well, and then you can always go back. You might want to go back and look at it. That's what's nice. Okay. What would you like for t? How about -2 to +2? Because the minute you get 3, you're doing 3 to the 4th. That's so big. That's a problem. Well, the y's are no problem. The y's are going to be between 2 and -2. And I don't know how big the x's are going to be, so guess what I'm going to do? I'm lazy, I'm tired, so I am going to bring up my calculator and let the calculator do the work. So we're going to go into second table set. We'll start at, well, -2 sounds good. And then we'll go second table. So the x's are going to go from 4. 3 isn't too bad. It's 54. It's not too bad, but maybe we just want to go to 2. And then when you do these, make sure you give us the direction. Okay? So the x's are going to go, they go down to -2. So we could go -3, but we got to get up to at least 4, and that looks okay. So window, I'm going to start at -2. And I know it doesn't make sense to go negative, but you really do want to do that to see it. And x minimum was negative, let's go -3, and then this was up to 5. How big do the y's get? Between -2 and 2. So let's make it -3 and 3. Does it surprise you that it's a W on its side? Because what's the 4th power look like? It's a W. 4th power goes. If you switch x and y here, if you have y equals x to the 4th minus 3x squared, that's a W. And what? That's not what that looks like. How is this related to that? They are what? Inverses. So you could have graphed this and then by hand reflect it over y equals x.
You're right. Wait, so you're very bad. How do I get to see the W if I want to see the half?
You have to have the right window. Your window. Remember, what did I do? I looked at the table, Ori, to figure out what the values were. I went second table. Well, just get involved. It helps. Yes. Some things you have to do by hand, but they're simple. You'll change them to Cartesian. No, it'll be simple. This is not simple. I mean, it's not hard, but it's busy work, isn't it? No, it's not on the quiz tomorrow. I went to my table because what happens if I make x become more negative? See, my window is going to be 54 then. I'm not going to see much if I increase my time to -3. I want my numbers to be close to the origin. So then I pick t-values that will do that for me. So the table is how I actually do it. Oh, now I lost my picture. I want that picture. And so back to my graph. Now, I still want my picture. Let's slow it down just a tad. And let's watch this again. Let's make that point 0.05. Whoops. See, Grant? Now watch this. You got to watch this because there's speed involved. What's it doing? It's stopping there. Speeds up, stops, accelerates. Yes, it does. Stop. Look how fast it's moving. Let's make our window bigger. Let's make this -3. And now we're going to have to fix our window a little bit. With the x's, yeah, the x's go up to 54. Now it's not going to be as nice. Also, I don't want that little circle trace on. I think it's making it not smooth. Graph. Uh-oh. Why did it stop? Because I stopped it too. And I'm going to slow it down even more. Nope. Now see, it slows down. It's going really slow there, but watch after it crosses the y-axis. It's going to speed up. It's just a little rough, that's all. So you get speed with these things. So if I were looking at this, I would want to look at also the direction. So you would say you start here, and it goes around like this. So that's what's cool about it. You can actually get speed with it. So you know what speed is. That's a derivative of your position. So you're going to be seeing this. This will be on the exam. The next, are we ready for the next one? That one. Anybody know what that's going to be a graph of? Well, can we make a table of values? Could you do this one by hand? Yeah. Okay, so I might ask you to do it by hand. Do you want to do it by hand? Oops, forgot the T. Well, -3, -2, -1, 0, 1, 2, 3. But I'm going to use my slope to help me. So at -3, let's go ahead and start at the beginning. I'm going to be what? -3 minus 1, -7. What's the slope? How fast are the x's increasing? So it's -5, -3, -1, 0, check. Whoops, 0. So I said check. 1, 3, and 5, right? That doesn't take very long. You can graph anything with the table of values. It just might take a long time. And back in the day when I was young, we didn't have graphing calculators. We did everything by hand. Everything. Okay. So when when t is -3, this is 5. Now what are these guys doing? The slope of -1, they're going down, right? No, all you have to do is start graphing it. You have to start at -3. T is -3. So, oh, and I'll show you a trace on this. -7, 5. I forgot to do that. So let's see. X is -7, and y is 5. Then x is -5, and y is 4. What am I going to get here? A line. Oh, I goofed. I wanted to cheat, but I can. What's the slope? No. No, I screwed up because I can't count. Okay, you're going to go over 2, down 1. Check. 1, 1. 3, 0. It's going this direction. So you're getting direction. You're not going to have the collision of 7 and 101 unless you're both in the intersection at the same time. You will intersect. Your paths will intersect. If you're going one way on 101 and someone else is going one way on 7. Yes. It allows you to see direction and the speed. This will be a constant speed. So it's nothing fun. There's no acceleration on this one. Okay, let's do this one. Now, some of these problems are really tough when you have to do the matching with the pictures. Those are not easy. You will substitute values in to figure it out. Okay.
Someone asked you, hold on, what is the Cartesian equation for the parametric equation?
I haven't done it. Let's graph it. I'm going to show you something. Well, yeah, let's go ahead and graph it. We have to get rid. It's called eliminate the parameter. So this is 2t minus 1 This is 2 minus t. Now, what about my window? Oh, I'm all set. Negative 3 to 3, but the x and y's aren't. What are the x's going to go between? Negative 7 and 5. So how about if we do negative 10 to 10, and what are the y's going to do? I made a table so I know. The y's go from negative 1, negative 3 works. I got to get up to 5. Doesn't go forever. This is how you would graph a segment. Parametrically. Give us the t-values. Hey, Grant? And this will have something to do with your vectors in college. So come after the AP exam, we really should do vectors because students have come back already this year and said, I wish we had done vectors because that's what's missing when you go on to the next course. They assume you know vectors. It's the equation of that line that contains that segment. Notice when I do a trace, because I forgot to do this yesterday, gives me my two equations and it gives you the t. And then you can go this way. See, so it gives you the t, x, and the y on the trace. Now, we'll do the Cartesians. I want to eliminate that parameter. Do you want y in terms of x or x in terms of y? You have to solve one of those equations for t.
Yeah, t over minus y. T equals 2 minus y.
So t is equal to 2 minus y. Is correct? Correct. I believe so. So then we substitute it in here. So x equals 2 times 2 minus y minus 1. Could you solve that equation for y? Yeah. That's the Cartesian equation. So did you want to look at any of the homework props now that we've done all these? You should have a book. David, this is brand new. You've never seen this before. And you'll see a Lissajous pattern here. Anybody know about Lissajous patterns in physics? Oh, you will. Letter, I think it's 1, Roman numeral 1 on page 77 is a Lissajous pattern. You're going to have to match. You're going to have to evaluate your function at certain places. Okay, so let's look at number 22. I got to see what I got here. I don't know, I have to think about that one. I just feel like I don't have enough information. Oh, yes. Now I remember. Oops. Okay, on page 77, take a look. Suppose I could take a picture. But on letter A, it's okay, but it's weird. This is number 22. Okay. What they're doing is kind of decomposing this. So what's the first order pair? It's xy. So the x is, when t is 0, what's the x coordinate? X is 1 and y is 0. Because this is just an x and time graph. This is just a y and time graph. Because that's the way they did it. Then they want you to have an x versus y graph. So on my x versus y, I'm going to start at, this is x, this is y, I'm going to start at 1, 0. Okay, guys, if you're not interested, the door's there. You're not going to be able to do this problem without some instruction. So don't whine at me. Yeah. Where is this? This is at a half, right? Now, halfway on the time here is what? It's 2. So x is equal to 2, and y is equal to what? Now, you're not expected to graph this. I don't think. Okay, so we have this point, and we have 2, 0. Now, look at the other graphs. I'm not going to draw them all. Is there anything that kind of matches that? No. And there's a y that's negative also, isn't there? What about at 3/4 of the 1 second or whatever? What about here? X is, I don't know, somewhere 1 1/2. And then y is -1. This is the x and y. That's why you need to pay attention. At this point, maybe I made a mistake, but at this point, this x is oh no, I did this, halfway. And then what about at this point? X is 1, and y is 0. So it looks like it's going to go through this point more than once, doesn't it? Now, when x is 1 1/2, y is -1. So I've got to have something that goes through these points. Which one is that? What do you think? Look at the pictures. It's 1, 2, 3, or 4. What's the only one that looks like it matches? Can't tell unless you look in a book, because I'm not going to draw them all. Which one is it? 1, 2, 3, or 4? I just tried it. All I did was take some random points that I could figure out, wrote down the x and the y, and then see which ones it would match. So it has to go through 1, 0 twice. Which one goes through 1, 0? There's only one of them. That one. Mm-hmm. Yeah, it's a very different way of thinking. Okay, Alex, you going to be able to get that? I did this point right here, so I said time is 3/4. It's just an estimate. Okay, so what's happening here? As x gets bigger, goes towards 2, what's the y value doing? It's getting bigger and bigger until it gets here, right? And then what happens at 2? Y is 0. Then what happens? X is now going to get smaller, so my x is going to go that way, and the y is going to become negative. So it's going to go around like this. Ends up back at the 1, 0. Okay, Eric, question? I have no idea how to do this.
I did too.
Okay, who wants to come up and do the next one? No.
Let's nominate.
Grant and Eric. There's your group. Okay, you need a book. I don't want to take the time to do that. You might be able to think about which one it is. So you have to draw B. Just mash them up. It's hard. This is not easy. At the same time, you will pull off the x and y coordinates. Yes. Mm-hmm. I'm doing work. You want to read it? Well, you're drawing. You're not doing anything. Okay, so now you're going to match it up. So when t equals 0, what are both x and y?
It's 0 and 0. Graph will be yours. E equals the next one, so that's like 0.25 is the next one. Let's do it. 0.25. So that's half. Negative 1.
Why don't you do the other endpoint? I always do the easy things first.
That one. So 0.
Johnny? So at the beginning it's 0. What?
We're doing t equals 0.25 here.
You can do whatever you want for t. What's the other endpoint? At the end, they both end at 0. You can't. I can't tell from their picture. I gotta look in a book.
Are you critiquing the picture?
No, but I'm just saying it's too hard to tell. If you have your book open, you guys can't possibly be listening. He doesn't. Yeah, you do. So there's their picture. One's a sine curve with 2 circles, with 2 cycles. And the other one is a sine curve with several cycles. Let's look at that one. Mm-hmm. Well, look at the answer. See which one makes sense. Which one's cycling? No, 1, 2, 3, or 4. We already eliminated one of them. Really hard one is 26. Okay? Which one did you say it was? Which graph? No, we already used B, didn't we? I know. Which graph does that match?
That's X, that's Y.
Oh, so you don't have your book open. That's why you don't know. You need to look in your book and see which one it matches. No.
You got too lippy, dude. You should have just called it good. I told you, man. I told you.
Which one of the red ones does it match? It's a matching problem. Now, when you guys come in here, you should be picking up a book. So tomorrow when you come in here, you're going to grab a book. Because when you're done with your homework quiz, you need to be working on it.
Got 1 at 0, at 0, 0, and at 1 at 0. Yeah, oh, no.
What do the rest of you guys think? Which graph is it? You guys even open your book and look?
No, we're not the only ones, man. Yeah.
Guys, you need to be opening your books and looking at this. Because how are you going to, so this lesson is absolutely meaningless if you're not looking at it. No, you didn't even know what the question was. Now you have it. So answer is going to be, it looks like it's 1.
Not that one.
It's cycling, which is the only picture that cycles and goes through the origin.
You gotta pick a red one.
So it can be 2 and
the 1.
And 4 doesn't even go through the origin. So it's between 2 and 4. So that's what you're going to do. You pick a point, see which one it is. Look at 26. Where's your book? Oh. Guys, you can't, I have no time to waste in this course. You do not have all of 4th quarter to prepare for the exam. I teach end of 4th quarter to about 2 weeks before the exam. If we work hard, it's a possibility of being close to being done by end of 3rd quarter. But if you drag your feet, it's not going to happen. And then I have to teach right up to the exam. You don't want to be in that position because you're going to be doing homework, learning new stuff, and reviewing. That is not a good place to be. So you need to be grabbing books when you come in here and working on things. And this stuff is all brand new. It's hard. So tomorrow, I expect you to come with some questions. I don't know what the assignment is. You have to look it up.